Hello, my name is Ashish Udgave. I am working as an assistant professor in Department of Mechanical Engineering, Sharad Institute of Technology, College of Engineering, Yedrao, Itzelganj. I am welcome to all in the lecture of Work, Power and Energy. In last video, we have covered concept of work done by spring and problems on work done by spring. Today, in video number 12, we are going to cover impulse momentum principle and problems on impulse momentum principle. It is clear from the discussion of previous videos that for solving kinetic problems involving force and acceleration, D'Alembert's principle is useful, and that for problems involving force, velocity and displacement, the work energy method is useful. In this video, the impulse momentum method is dealt, which is useful for solving problems involving force, time and velocity. Linear impulse and momentum. Let if R is the resultant force acting on a body of mass m, then from Newton's second law of motion, we know that R is equal to ma. But acceleration, we know that acceleration a is nothing but rate of change of velocity with respect to time. Therefore, we get a is equal to dv upon dt. By putting value of a in above equation, we get R is equal to m into dv by dt. That is, R into dt is equal to m into dv. Integrating both these sides, therefore, integration of R into dt is equal to integration of m into dv. If initial velocity of the body is u and after time interval t it becomes v, then integration of R into dt limits from 0 to t is equal to m into v limits from u to v. Therefore, we get m into mv minus mu. We will call this as equation number 1. The term integration of R into dt limits from 0 to t is called as impulse. If the resultant force is in Newton and time is in second, then unit of impulse will be Newton second. If R is constant during time interval t, then impulse is equal to R into t. The term mass into velocity is called as momentum. Therefore, now m into v is nothing but we know that W is equal to mg, therefore m is equal to W upon g. Therefore, we get m into v is equal to W upon g into v. Substituting dimensional equivalence, we get Newton into seconds. Thus, the momentum has also unit Newton second. From the equation 16.1 satisfies that the requirement of dimensional homogeneity. The equation 16.1 can now be expressed as impulse is equal to final momentum minus initial momentum. We will call this as equation number 16.2. Since the velocity is a vector, impulse is also a vector. The impulse momentum equation holds good when direction of r, u and v are same. Impulse momentum equation can be stated as follows. The component of resultant linear impulse along any direction is equal to change in the component of momentum in that direction. The impulse momentum equation can be applied in any convenient direction and the kinetic problems involving force, velocity and time can be solved easily. First problem. A glass marble whose weight is 0.2 Newton falls from a height of 10 meters and rebounds to height of 8 meters. Find the impulse and the average force between the marble and the floor if the time during which they are in contact is 1/10th of second. In this problem, a glass marble of weight 0.2 Newton falls from height of 10 meters. Therefore, by applying kinetic equations for easily falling body, the velocity of which the marble strikes the floor is equal to under root twice gh. Therefore, we get velocity with which marble strikes the floor is equal to 14.007 meter per second in downward direction. Similarly, applying kinematic equation for marble moving up, we get velocity of a rebound is equal to under root twice gh is equal to we get velocity of a rebound is equal to 12.528 meter per second in upward direction. We will call this as equation number 2. Taking upward direction as positive and applying impulse momentum equation, we get impulse is equal to W upon G into V minus U, that is final momentum minus initial momentum. By putting all these above values, we get impulse is equal to 0.541 Newton second. If F is the average force, then we know that F into T, that is nothing but impulse is equal to F into T is equal to 0.541. We know that T is equal to 1 upon 10. Therefore, by putting above values in this equation, we get F is equal to 5.41 Newton. Therefore, answer of this problem, impulse is equal to 0.541 Newton second and average force F is equal to 5.41 Newton. Next question. A block weighing 130 Newton is on an incline whose slope is 5 in vertical and to 12 horizontal. Its initial velocity down the incline is 2.4 meter per second. What will be its velocity 5 seconds later? Take coefficient of friction at contact surface is equal to 0.3. In this problem, given entities are slope of inclined plane is 5 vertical and 12 horizontal. Therefore, we get theta is equal to tan inverse of 5 upon 12 is equal to 22.62 degree. Now, block of weight 130 is on inclined plane. Therefore, weight of block is acting always vertically downward direction. Normal reaction N is acting perpendicular to the supporting surface. Since body is moving in downward direction, therefore force of friction must be in upward direction. Therefore, by applying summation Fy is equal to 0, we get N is equal to W cos theta, that is equal to 120 Newton. We know that F is equal to mu into N, where mu is nothing but coefficient of friction between contacting surfaces is equal to 0.3. Therefore, we get F is equal to 36 Newton. Now, summation of forces down the plane is equal to R is equal to W sin theta minus F. Therefore, we get R is equal to 14 Newton. Now, given entities are initial velocity of the body U is equal to 2.4 meter per second. Let V be the final velocity of the body and time interval T is equal to 5 seconds. By applying impulse momentum equation, we know that according to impulse momentum principle, impulse is equal to change in momentum or final momentum minus initial momentum. Therefore, R into T is equal to W upon G into V minus U. Therefore, by putting above values in this equation, we get V is equal to 7.48 meter per second. Therefore, answer of this problem, final velocity of the body V is equal to 7.68 meter per second after 5 seconds. Problems on connecting bodies. First problem, determine the time required for the weights shown in figure A to attain the velocity of 9.81 meter per second. What is the tension in the cord? Take mu is equal to 0.2 for both the planes. Assume the pulleys as frictionless. Here, free body diagram for both the bodies is shown in figure B. In this problem, 1800 Newton body will move in downward direction and 2000 Newton body will move in upward direction. Let T be the tension in the cord. Since weight of both the bodies are acting in downward direction, therefore 2000 Newton will acting in downward direction and also Wt is equal to 1800 Newton acting in downward direction. Let N1 and N2 be the normal reactions of both the bodies and these are acting always perpendicular to the supporting surface. Since 2000 Newton body moves in upward direction, therefore force of friction F1 must be in downward direction. And as 1800 Newton body will move in upward direction, therefore downward direction, therefore force of friction F2 must be in upward direction. For now, considering 2000 Newton block, we know that applying summation Fy is equal to 0, we get N1 is equal to W1 cos of 30. Therefore, we get N1 is equal to 1732.05 Newton. We know that F1 is equal to mu into N1. Mu for all the contacting surfaces is 0.2. Therefore, we get F1 is equal to 346.41 Newton. Now, considering 1800 Newton block, we get by applying summation Fy is equal to 0, we get N2 is equal to W2 into cos of 60. Therefore, we get N2 is equal to 900 Newton. Since we know that F2 is equal to mu into N2, therefore we get F2 is equal to 180 Newton. Let T be the tension in cord. That we know that initial velocity of the body u is equal to 0 and final velocity is 9.81 meter per second. By applying impulse momentum equation for 2000 Newton block in upward direction parallel to the plane, we get T minus 2000 sine of 30 minus F1 into T is equal to 2000 divided by 9.81 into V minus U. Here 2000 Newton block moves in upward direction, therefore upward direction forces are taken as positive and downward direction forces are taken as negative. Therefore T must be upward direction, 2000 sine of 30 must be downward direction and F1 must be downward direction. Therefore T must be positive, 2000 sine theta must be negative and F1 must be negative. By putting all these values in this equation, we get an equation capital T minus 1346.41 into small t is equal to 2000. We will call this as the equation number 1. Now, by applying impulse momentum equation for 1800 Newton block in the direction parallel to the inclined plane, we get 1800 sine 60 minus t minus F2 into small t is equal to 1800 divided by 9.81 into V minus T. Since here 1800 Newton block will move in downward direction, therefore downward direction forces are taken as positive and upward direction forces are taken as negative. Therefore 1800 sine of 60 must be positive, capital T must be negative and F2 must be negative. By putting all these values in this equation, we get an equation 1378.85 minus capital T into T is equal to 1800. We will call this as the equation number 2. By dividing equation 1 by equation 2, we get capital T is equal to 1363.48 Newton. Substituting capital T is equal to 1363.48 Newton in equation 2, we get small t is equal to 117.11 seconds. Therefore, answer of this problem, tension in the cord T is equal to 1363.48 Newton and the time required for the weights to attain a velocity of 9.81 meter per second is equal to T is equal to 117.11 seconds. Now next question. Determine the tension in the strings and the velocity of 1500 Newton block shown in figure A 5 seconds after starting from small a rest and small b starting with the downward velocity of 3 meter per second. Assume pulleys as weightless and frictionless. Now in this problem 1500 Newton block will move in downward direction and 500 Newton block will move in upward direction. When 1500 Newton block moves a distance s, in the same time 500 Newton block moves the distance twice s. Hence, if the velocity of 1500 Newton block is v meter per second, that of 500 Newton block will be twice v meter per second. Let T be the tension in the cord connecting 500 Newton block. Hence tension in the wire connecting 1500 Newton block will be twice T. Since velocities of two blocks are different, only first method is to be used. Now case first, starting from rest, initial velocity u is equal to 0 and t with the 5 seconds. Writing impulse momentum equation for 1500 Newton block, we get capital T minus 1500 minus 500 into small t is equal to 1500 divided by 9.81 into twice V minus U. Since in this equation 1500 Newton block will move in downward direction and 500 Newton block will move in upward direction. Therefore, first of all, by considering 500 Newton block, as this block will move in upward direction, therefore upward direction forces are taken as positive and downward direction forces are taken as negative. Therefore, T should be positive and 500 Newton should be negative. By putting above values in this equation, we get an equation capital T minus 500 is equal to 200 V divided by 9.81. We will call this as equation number 1. Now, applying impulse momentum equation for 1500 Newton block, we get 1500 minus twice t into small t is equal to 1500 divided by 9.81 into V minus 0. Since 1500 Newton block will move in downward direction, therefore downward direction forces are taken as positive and upward direction forces are taken as negative. Therefore 1500 should be positive and twice t must be negative. By putting above values in this equation, we get equation 1500 minus twice t is equal to 300 V divided by 9.81. We will call this as equation number 2. By adding equation 2 in 2 times equation 1, we get small v is equal to 7.007 meter per second. Substituting it is in equation 1, we get capital T is equal to 642.86 Newton. Now, case B, starting from an initial velocity of 3 meter per second. Therefore, initial velocity u is equal to 3 meter per second. By applying impulse momentum equation for 500 Newton block, 500 Newton body, we get T minus 500 into 5 is equal to 1500 500 divided by 9.81 into twice V minus 3. Therefore, we get capital T minus 500 is equal to 100 multiplied by twice V minus 3 divided by 9.81. We will call this as equation number 3. And applying impulse momentum equation for 1500 Newton body will be 1500 minus twice t into 5 is equal to 1500 divided by 9.81 into V minus 3. Therefore, we get 1500 minus twice t is equal to 300 divided by 9.81 into V minus 3. We will call this as equation number 4. Adding equation 4 and 2 times equation 1, we get small v is equal to 9.15 meter per second. Substituting v is equal to 9.15 meter per second, we get capital T is equal to 655.96 Newton. Therefore, answer of this problem: tension in the strength when body starts from rest is equal to 642.86, and when body moves with a downward velocity of 3 meter per second, tension in string will be 655.96 meter. Please note that this video is prepared for academic use only. To understand the concept of impulse momentum method and to solve the problems on impulse momentum method for UG students only. Thank you. Thanks a lot. For any query, please feel free to contact me on mail or on mobile. Thank you.